R Programming Simulation Part 2.
How to apply the simulation process to the statistical analysis. For illustration, I will conduct the simulation for one sample t-test by applying the data from example 99. So this is the data from the example 99, which is the data of mineral water. The volume of mineral water sold at hypermarket supposed to be 600 ml per bottle. We have a random sample of 10 bottles, and then the volumes recorded are as follows. The quality manager at the hypermarket detected that the volume of mineral water is more than 600 per bottle. Test whether the claim made by the quality manager is true or not at 5% level of significance. So I will use the data to run the one sample t-test, and at the same time I will use the information based on this data to generate a simulated data. So let's say this is the data. Okay, I will find the mean and the standard deviation, mean of the water and the standard deviation of the water, because I want to generate the data with the same distribution as the original one. So this is the mean and the standard deviation. So let's say if I want to generate a simulated data based on this information, and then we assume that the data come from the normal distribution. So we use the set.sit. In this case, I choose 100. Actually, you can choose any value here, but if you want to get the same answer as mine, so make sure that you set the same set.sit number. Let's say the same data, mean is the same water, come from the normal distribution, and then we want to generate 10 observation because the previous one there are 10 observation, with the mean equal to, just follow this one, 601.64, and then the standard deviation equal to 2.168051, and then run. And then this is the data for the simulated one. So you should get the same value as mine because we use the same set.sit number. Okay, so if I run the test, one sample t-test. Okay, let's say I use the original data first. Okay, test mu equal to 600, and then the alternative is greater, and then the confidence interval equal to 95%. Okay, and then run. So I will get the test value equal to 2.3921, and then let's say we run the t-test for the simulated data, sim water. Okay, so the test value for the simulated data is 4.1618. okay, so if the simulated value is close to the actual values, so which means that the normality assumptions are satisfied. Even though, as you can see, that the test value for simulated one Okay, is far behind the actual one. Okay, just please bear in mind that the simulated values supposed to run more than once. In some cases, we can run a simulated data up to 10,000 times. So let's say we want to run a simulated data 100 times. So how to do that? We use the function of replicate. So let's say we replicate 100 set of simulated data and then run the t-test on the data which is come from the normal distribution, 10 observation, mean 601.6, standard deviation 2.17, and then mean equal to 600, and then okay, we use the dollar sign to get the statistic. Okay, actually let's say from here copy. Okay, so let's say we only want the statistic. Sorry. Statistic. Okay, actually we only want to get the value of t 2.39073, so therefore we only choose the statistic. Okay, so to run 100 observation, so we use the replicate. Okay, and then run. Okay, so if I click Simon, run Simon, I will only get all the test value that obtained from the t-test here. And then if I compute the mean of the Simon, so I will get on the average the test value is equal to 2.597146. So now the test value is close to the actual one. So remember the actual one, the test value, this one, the test value is equal to 2.39, so it's close to the simulated values.
Thank you for watching.